Thank you, everybody. I'm quite humbled, actually, to be able to talk about some of the things I'm doing here at Schlumberger. I put together a short presentation. I don't expect it to take more than 30 minutes. I've listed an outline here of what I'm going to cover. If you have questions, please click on that Q&A interface and send them. I think we'll have a lot of time to discuss them. My goal is to just kind of explain how I think this particular process fits in or might impact software development. It's certainly proven for a lot of mechanical systems designs. And recently, I've done a couple projects trying to use it in the software domain, and that's what I'll be talking about. I do know, at least inside Schlumberger, there's a lot of arguments as to whether software and hardware are different design processes and whether or not the same tools and rules should apply to both of them. And at least inside my parent company here, generally they are different and different processes are used. So this has been an exploratory effort for me. Moving forward then, the scope of the presentation here, I'm getting my controls. Yeah, I'm going to talk about a process to document the functional design, all right, which is a requirements analysis, a concept synthesis, and a robust assessment. It's an upfront early process. I'm starting in terms of a box diagram with business goals and then the stakeholders. And then my outputs at the end of this point, this phase, will be just 4 things. We'll have top-level functional requirements and acceptance tests. We'll have what we call a functional design decomposition, which is actually kind of a concept proposal. We'll have a user story list, and then I'll have a risk assessment and a mitigation framework that will have been built around that functional decomposition. And I do want to talk very precisely here about functions. It's a vocabulary and it's a real difference. Generally, in most places I've experienced, at Schlumberger as well, a lot of times requirements documents are feature documents or solution documents. Often they are user story documents. And in the axiomatic design process, we are trying to get away from defining systems in terms of their solutions, but rather define them in terms of their functions. It's a really important distinction and sometimes hard to get people to do, myself included. My example here is there shall be a ringer on a phone design, a very simple type of requirement. And in the axiomatic design framework, we're going to argue that is not a requirement, a FR, a functional requirement. In fact, that's a solution or a feature. We call them DPs, design parameters. The function is notify the user of an incoming phone call. And we would ask people to define the requirement in the function space. Okay, so why do we want to do this? The most compelling reason is that if you define your requirements in the solution space, which is really common, you've lost your vision of the overall problem. You immediately don't look at alternative solutions. Your requirements document puts your requirements authors in the business of making design decisions, which is intrinsically wrong. And then it's very difficult to assess whether or not you've done a good design if you've been given solutions as your requirement. Now, I often joke and say if a management wants to squash innovation and eliminate any dissent and maybe force the project to match their particular agenda, then defining requirements in the solution space is a good thing to do, but not in axiomatic design. That's my scope here. I'm now going to talk about axiomatic design itself as a process. I think most people are probably not familiar with it. It was developed at MIT, and if you wanted to, you could certainly take a class there. It runs about 3 months, meet twice a week, and spend a lot of money. Well, you can bear with me here for about 15 minutes. I have an abridged version that I think works somewhat well. The process was developed by Professor Nam Su in order to address what he called problems in design processes. He gives an example, or I use an example. If you have 10 designers and you give them a problem and ask them to come back the next day with a solution, invariably you'll get 10 different solutions, maybe 15 if they're really creative. However, if you think of quality and quality processes, you know, they say variability is the enemy of quality for those people who are Six Sigma or Lean practitioners. Therefore, if 10 designers produce 10 results, which is a scattergram, you would argue by definition there is no quality in the process that they are applying. And the professor said, well, if I'm going to bring repeatability such that 10 engineers or designers come back with the same solution as the best solution, somehow I have to eliminate this variability on how they synthesize their solutions. And he came up with axiomatic design. It's actually a way of thinking about solving problems. It's a hierarchical, top-down decomposition method. It operates in the functional domain. And we ask people who are practicing it to identify the functions and their proposed solutions or features as part of the decomposition. And then the process asks the practitioners to structure the relationship between the functions called FRs and the DPs in a square matrix called the design matrix, and I'm going to talk about that in the next slides. As I review this here right now, I want people to try to understand what's being preached. There's a lot of arguments against it, but if you understand first how they think about it, then at least it's easier to understand how you might apply it. Axiomatic design will argue there's only 4 kinds or 4 buckets or 4 domains of information in a complete design process, and they're represented by the 4 domains of screen here. And at the very left is what's called the customer needs or customer domain. And then there's a functional domain, which is the FR domain. Then there's this solution or DP or design domain, often called the physical domain. Different academics call them different names. And then finally on the right-hand side there is the process domain or the implementation domain. And that all the information in a complete design is contained in one of these 4 domains or buckets of information. And that the axiomatic design process itself is a mapping process where you start on the left and move domain by domain to the right, asking the simple question, what do I want to achieve? How do I achieve it? What do I want to achieve? How do I achieve it? So there's a cause and effect from left to right. My example here is a simple example. Where's the beef example? If you're going home tonight and you're typical American, you like a hamburger, you buy some ground beef at the store, and you get home and you realize you're not going to use it, you put it in the refrigerator. Why do you put it in the refrigerator? Why? Because your need was to preserve it, and of course you jump to solutions that are in your personal experience, which is the refrigerator. Most people do design like this. They take a look at the needs, look at their personal experience, design experience, and then select that implementation, either refrigerator, and jump to it. And that's how they process their design. Axiomatic design says, no, let's stop, let's change this thinking process as we analyze problems, and let's pass through intermediate domains and populate them. The intermediate domain here, the functional domain, what do I want to do? I want to preserve beef. How can I do it? The function here would be stop the growth of bacteria. There might be several functions actually. Stop the growth of Escherichia coli, stop the growth of Salmonella, maybe stop oxidation, maybe prevent further contamination. All of these would be functions necessary, measurable to achieve that particular need of preserving beef. And then likewise, we map into the next domain, which is how can I stop the growth of bacteria? And in this particular case, we have a number of